So before this whole coronavirus outbreak began, we were starting to talk about web application security. We discussed how typical web applications consist of a browser that renders pages to end users, but also where JavaScript can execute and where users can provide input to be sent back to the web server. And then we said there's a whole bunch of vulnerabilities that can come with situations like that. So let's take a look at some of the slides that we presented back then. One of the first things we brought up was the top 10 put together by the Open Web Application Security Project. We discussed injection vulnerabilities by looking at SQL injection, and we saw that if you are vulnerable to SQL injection, a whole lot of badness can happen. We can have authentication bypass systems. We could have situations in which people can manipulate the data in the database, maybe even drop the database altogether or add information to it. We could have situations where people select more data from the database or different data than the developer expected. The basic lesson is that if you're vulnerable to a full SQL injection vulnerability, the database is basically under the full control of whoever's attacking you. And in most attacks, that's exactly what an attacker is looking for, right? The data in the database. So that's bad. We saw that you don't want to necessarily keep security state in the browser because the browser is fully under the control of whoever is using it. And if that happens to be an attacker, then the attacker fully controls the browser. We saw that when we started looking at things like cookie manipulations or sniffing credentials out of a browser session. We also saw that if we look at the browser's URL window and we play with the URL, maybe remove the last file name or increase counters or whatever it may be that we can do by manipulating the URL manually, we might tease the system into behavior that it wasn't meant to do. All of those are known vulnerabilities that we've so far played with in the capture the flag session. Next, I want to look at cross-site scripting. So let's consider this situation. As an attacker, let me go nice and shiny in red. Attacker, through whatever mechanism, I discovered a vulnerable web server. A web server that is vulnerable to cross-site scripting. In this particular case, instead of reflecting the JavaScript, for example, the injected content, I'm actually storing it in a database. Say, maybe I have a blog or something that is susceptible to cross-site scripting, and whoever is reading my blog posts gets the injected script back from the database and echoed back to them. So in this particular case, I am an attacker. I was able to inject some content into the vulnerable web server, and at that point any victim that visits that same web server will also return my malicious content to that victim. That is the basic concept of cross-site scripting. So the attacker injects their HTML or whatever it may be that's valid in a web page into the web server. The web server may store it in a database. In that case, it's no longer called reflected cross-site scripting, but now it is called stored XSS. And whoever visits that web server and pulls the content from the database at a later point will be getting the content that I put in there. So let's take a closer look at what cross-site scripting looks like from the browser side. I've opened a page on the computer science server. It's called hello.php, and really all it does is say hello. The current time in Garden City is, and it prints the time. It also lets you enter your name, and when I do that and hit submit, it just echoes back hello Leune. Now, as a web security person, I go, that's interesting. For example, what would happen if I put that in my screen. H1 between sharp brackets and then /H1, that's an HTML control character. And that means that if this is echoed back exactly the way it's entered, I am actually changing the way that my page renders. So let's take a look. And it does. That means we can do nasty things as well. For example, we can go font size equals, let's go with 1%. Does that work? Becomes very small, but not small enough. But maybe we can do something like this. Div style equals, is it this? Font color white. And now we see that my text completely disappears, and I do not see what I output. I may be able to do something. No, there is nothing there. Right? So there's all kinds of stuff we can do with that. This is your basic cross-site scripting vulnerability. Whatever I put in here gets echoed right back to me. That's not such a bad thing, because at that point I would be attacking myself. But if we look closely at the URL bar, it means that everything I just put in is up here as well. So hello renders it hello hello over here, and that means I can send this URL to someone, and then the JavaScript doesn't execute in my browser, it executes in theirs. So that's called reflected cross-site scripting. So many other things we can do other than just this, but this is a good start.